Hello YouTube. In today's video I am going to show you how I build my own surface mount board designs. For this demo I'll be using the NRF24L01 Plus dev board with power amplifier that I designed in KiCAD. The process consists of three main portions: applying solder paste to the board, populating the components, and running the board through a reflow oven. Here I am getting ready to apply paste to the board. Now just a little bit about the materials. I have a stencil and the board. The board is from Oshpark, which is a really great source for cheap, low-volume boards. The quality is also great as well, and the only thing I've noticed so far is that some of the pads on the QFN package extend into the trace. But other than that, I've been quite pleased with all the boards I've received from them. If you want to know more about Oshpark, Contextual Electronics has a great segment in their KiCAD tutorials where he actually goes through and shows you exactly what you need to do to order boards through their website. The stencil I am using is a stainless steel stencil from Osh Stencil. The stainless steel is nice and will last you as long as you need it for. However, the one thing I will note when purchasing a stainless steel stencil from Osh Stencil is that the default border width on the stencil wizard is quite large. I was a little sticker shocked when I ordered this one, but then I went back to their wizard and reduced the border size, which cut the cost drastically as they use a tiered pricing system. I also got these holders from Osh Stencil. They are not necessary, as you can just use some scrap PCB to secure the board in place, but I like them, and it's always nice to support the small companies that make convenient DIY electronics possible. For this project I am using a leaded solder from DigiKey. I would prefer to go with the lead-free solder, but I don't know if my reflow oven would be able to meet the higher temperatures required for most lead-free solders, so I'm playing it safe for now and going with the leaded. Now that I've talked a bit about the materials, applying the solder is relatively straightforward. As you can probably tell already, I have taped down the holders and secured the board within them, and I have also taped the stencil down so that it is aligned over the board and a nice hinge line has been created. Mix the solder thoroughly before use. And then to spread the solder over the board, just apply a somewhat generous amount on the front of the stencil across the entire width of the board. Then, taking a credit card or the Osh Stencil supplied spreader, work it into the solder paste. Then, at about a 45-degree angle, spread the solder paste over the stencil with firm and even pressure. The stencil is the perfect height for the solder application, so you do not want to leave a thick film over the entire stencil, but you also don't want to push so hard that you pull the solder out of the pad slot. Now that solder has been applied over the stencil, lift the stencil off the board, being careful not to smear the solder. If you notice slight bridging in between some pads, it could be alright. During the reflow process, the solder will naturally wick towards the pads, so small solder bridges may straighten themselves out during the reflow process. How much imperfection you can get away with, however, can only be determined through trial and error experimentation. Now that solder has been applied to the board, it is time to place the components. Tweezers are an absolute must when placing surface mount components. You could also invest in a manual vacuum-operated pick-and-place pump, but when you're just starting, it is definitely not worth the investment, and a pair of tweezers works just fine. Another note, ESD can be an issue when working with electronic devices. In this video, you will not see me wearing any sort of ESD protection. I haven't been working with any devices that are incredibly expensive, but if you are and you don't want to take any risk, purchase yourself an anti-static wrist strap and mat. Placing all of the components on the board can be a bit tedious, especially if your board contains a lot of components. Normally I order all of my components through DigiKey, and when they get to my house they come packaged individually in a bunch of bags. I simply set the bags in a pile next to the board and grab one at a time, always keeping the schematic right next to my workstation for reference. In this demonstration, the first component I grab is a 1 picofarad capacitor, which is C11 on my schematic. I gently grab the component with the tweezers and place it on the board, nudging it into place if need be, but being careful not to smear the solder too much. Similarly to the solder bridging point I mentioned earlier, The components do not have to be placed absolutely perfect on the board. During the reflow process, the components will naturally be pulled towards the pads and will straighten out to some degree. The biggest opportunity for error in this process is placing the component backwards. This isn't a problem for most passive components like resistors and capacitors, as they are usually non-polar, but for polar components like diodes, make sure you place them in the correct orientation or your circuit will not function correctly. This is what my board looks like after placing all of the components. It is now ready to be sent through the reflow oven. This is my reflow oven. It is a bit rudimentary right now. For the projects I wanted to develop, I knew I would need a reflow oven, but I didn't want it to take a bunch of time away from those projects. I would probably do a video in the future cleaning up this oven and making it look nicer, but for now it does what I need it to do. It is for this reason that I'm not actually going to show the board in the oven in this video. If you make your own reflow oven, make sure you are working in a well-ventilated area. Also, it is always a wise choice to take some extra precautions when modifying equipment outside of its intended purposes. I never leave my reflow oven unattended when operating it, and I always keep a fire extinguisher nearby just in case. Alright, so I've given the board some time to cool, taken it out of the oven, and for the most part it looks pretty good. However, when you're fabricating electronics, things don't always go perfectly. On this board, the resistor R11 actually lifted vertically on one pad. Fortunately, the datasheet actually pointed out that this component was optional and not necessary. However, I will probably just fix it up later with a soldering iron when I solder the through-hole terminals and the SMA connector into place. In the next video, I plan on performing a range test using this board as a transmitter and a previous revision board as a receiver. I want to also thank you for watching this video. I hope you found it informative and stay tuned for the next episode.